Hi, my name's Dave Rich. I'm a verification architect with Siemens EDA. Currently, I'm the technical chair of the SystemVerilog IEEE 1800 working group. I'm going to talk about some of what's next for SystemVerilog in the upcoming IEEE standard. If we take a look back at the history of SystemVerilog, well, Verilog was first released in 1985 as a proprietary language. And it wasn't until 10 years later in 1995 when it became an IEEE standard. And then there were a number of IEEE standards released in 2001, and then in 2005 was the last release. And SystemVerilog actually took over and replaced Verilog in 2009. Now, if we look back at the revisions of SystemVerilog, well, SystemVerilog first started out as an Accelera standard, which was a set of extensions to Verilog. And there were a number of releases until it became an IEEE standard in 2005, but it was still an extension of Verilog. And again, it wasn't until 2009 that the Verilog standard got merged into SystemVerilog, and we had one standard. And then a number of years later, we had a couple of releases, and the current standard was published in 2017. And now, 6 years later, we're trying to get out the next version, which is 2023. Now, there's always this dilemma that we're in between new and improved versus trusted and proven. People want stability with their existing tool ecosystems. They don't want to see a lot of change. And anytime there is change to the language, they see that as instability. And that has to be compared with the need for improving productivity by enhancing the language to meet the objectives of the technology at hand. So the 1800 standard is composed of a working group that was formed in 2020, and that's an entity-based group, meaning each one of these companies has one vote in the standard. And around that time, we gathered issues to be addressed and approved by the end of 2023, and we hope to have that officially published in 2024. And the IEEE uses what's called a Mantis tracking database. It's used for a number of different standards between Accelera and the IEEE, and we have about 3,300 issues captured since we started the system in 2004. And as of now, there's still 1,100 issues still open. So when we take a look at these issues, we break them up into three basic categories. The first one is a set of enhancements, and those are new features that extend the capabilities of the language. And some of these enhancements may already be implemented in some tools, or they could be completely new features. And a lot of times these new features are borrowed from other language, so the use models are well known and well thought out already. The other category is errata, and those are mistakes in the current LRM, and so those could be very small typographical or editing errors, or there could be major contradictions in the text between the different LRM sections. Sometimes the current wording of the LRM is obviously incorrect, and tools have already made the fixes, and what we're just trying to do is make the LRM say what it should have said in the first place. And then the third category is clarification, and this is when we have missing pieces of text or misleading pieces of text where the LRM makes things ambiguous. And most of the time this doesn't involve a change to a tool's behavior unless the tool's already implemented something very different from the original intent. Now sometimes the line between all of these categories is fuzzy. We don't really spend a lot of time arguing over what should be an errata versus a clarification. But the intent here is to try to make the LRM as close as possible to what users and developers expect to implement, so there's not a lot of divergence in tools. And also when new tools get developed, we don't want to see differences in implementations. So that's the end goal here. So next I'm going to go through just a few of the enhancements, clarifications, and errata. And I'm just going to go over a couple, just going to go over several enhancements. At the time that I got this presentation together, there were 32 enhancements approved. And let's go over some of those. The first enhancement I want to go over is Mantis 4703, extending cover groups. And this is probably one of the key enhancement requests that at least motivated me to get the next revision of the standard out. And this has been a very often requested feature. What this enhancement does is allows us to add a new cover point in an extended class and crossing it with an existing cover point in the base class. The other thing it gives us is the ability to replace the bin structure of an existing cover point or even remove it entirely. So in this example, the base class, Pixel, has two different variables that we're covering, a level and a mode. And then we're going to extend this class and add an additional variable, color. And in this extended cover group, we're going to give it repeat the cover point B, and that's going to essentially override the existing cover point B in the original cover group. And we're going to ignore the bin reverse. So that's not applicable to a color pixel. And then the other thing we're going to do is cross level and color. And level in this case comes from the base class. So we still only construct one cover group, G1, in the class, but it gets extended just by the fact that we've extended the class and the cover group. Another enhancement is unpacked array map function, Mantis 7610. And this is an example where we've taken a feature from another language like Python that has a mapping function to deal with unpacked arrays. And so a couple of things that we can do with this feature is we can make assignments between arrays with unequivalent types. So for example, we have an array of integers, an array of bytes, and currently in SystemVerilog you can't make an assignment from B to A or A to B. But with the mapping function, what it does is it creates an iterator that for each item of array A, we're going to replace it with a casting of each element and assign it to B. That's one thing we can do. We can also perform an operation on each element. For example, if we wanted to increment every single byte of the array, we can say B map with B equals with B plus 1 basically. Or we could add two different arrays together and create a third array. The next enhancement is 1084, and that's an if-def of a Boolean combination of identifiers. So what this does is allows us to use an if-def of an expression, anding or oring, to see if a bunch of defines have been there or not. So the way we currently do this in SystemVerilog is we have to create a bunch of nested or a series of if-defs and then create a temporary define, in this case A and B or A or B, and then it's just very messy. So on the right hand side we see we can do if-def A and B, or we can do if-def A or B, and the key here is that expression is in parentheses. Another enhancement that was taken from another language was multi-line strings, Mantis 7308. And what this does is it gives people the ability to write informative or self-documenting message so that it can easily be read and maintained within the source code. So it just makes messages much easier to read. You can put quotes in or new lines in the middle of the string without having to escape the characters. And in order to get this enhancement in, we had to address a lot of other issues that were already in there. You can see from these low Mantis numbers that they're 1397 and 1507 that they were pretty old. The next issue I want to cover is actually a pair of issues that are very similar. Mantis 7295 and 7669, which involve real number modeling in constraints and cover groups. So in both of these issues revolve around a problem that people have dealing with real numbers in a binary format. A lot of times we get these numbers like a decimal fraction, 0.1, is not representable as a binary number. It's a repeating pattern. And if you try to write an equation like 0.1 plus 0.2 and check to see if that's equal to 0.3, because of rounding errors, that's not true. And so constraints and cover groups were all designed around discrete values and ranges in integer numbers. So we had to make a couple of enhancements to deal with this. And so typically what we want to do when dealing with real numbers is put things in terms of tolerances instead of equalities. So if we want to, if we have a simple constraint, we can still do a value equal to 0.3. But as soon as we get more complex expressions, then we want to look at a range of values rather than an exact value to allow for the rounding errors. So we've added an absolute tolerance plus slash minus, and a relative tolerance in percentage plus percent minus, and that's essentially equivalent to the inside operator using a range of values, so that it should catch the value that we're looking for within a particular tolerance. So when we went to the actual implementation of reals and constraints, it was just a relaxation of certain rules, and it didn't require any new syntax or any additional rules. It was just removing rules. When we have reals in cover points, it required a couple of new options and range rules. So typically when we have a range, we have a discrete set of values that we want to map, that we break up the range into. And this option real interval uses a fractional range to break up the number. And we also want to deal with the fact that there's non-overlapping values. So in the range 1.0 to 1.5, and if the interval was 0.2, then that creates three different bins: 1.0 to 1.2, 1.2 to 1.4, and the last range 1.4 to 1.5. And notice in the last range we want to make the range inclusive. We had to use less than or equal to, where the other ranges were just less than. The next enhancement is chaining of method calls, 2735. And this is a feature that is actually implemented in most tools already, but it's just not in the LRM. Somehow it just got left out. And this is when we want to use the result of a function to serve as an intermediate variable for selecting a member of that result. So it's mainly used when we have classes. And a problem that we had is that for static functions, it's already possible to select a member, a static variable that's inside the function. So in this function A, you can actually say f.member, and that's currently legal, and that selects the variable member that's the static variable inside the function. But if what we really want is to use the result of the function and then use that as a class reference to select the member which is a member of the class. So by putting the parentheses after f, that uses the return value, which is a class handle, and then we select a member of that class. And then the last enhancement I want to go over is Mantis 2583, adding the static ref qualifier to arguments of a function or task. Calling functions with ref arguments is problematic when we have automatic variables, because the lifetime of an automatic variable is changed by certain constructs. Like if we do a non-blocking assignment, use a for statement, or use a fork join, the lifetime of an automatic variable is not directly tied to the task call. And when we call a function, we don't really know the lifetime of the variable that's being placed. So we can call a function many different times in many different call spots, and sometimes that could be static variables, or sometimes the arguments could be automatic variables. Inside the function we just don't know, and so we have to place these restrictions that you cannot do certain things with variables passed in by ref. So what we did is we added this qualifier, ref static, and that's a guarantee that the variable that we pass into the task or function is in fact a static variable. In this case here we've got a logic variable C, which is a static variable, and we're passing that into the monitor function. And then inside the monitor function we can then fork off a forever loop, and it's okay now to have that argument referenced, since we don't have to deal with extending lifetimes. Next, I want to cover errata. I'm just going to point out 2 errata as examples. There were actually 109 errata that we dealt with. So the first one is a clocking block name is not really equal to its associated clocking event. And there's this text in the LRM that says, in this case here we're defining a clocking block DRAM, and that means we can use the clocking event at DRAM, and the text currently says that statement is equivalent to writing at posedge phi1. But that's not true, because we know that a clocking block in a different section says that the event gets triggered in the observed region. So that already means that these two events can't be equal to each other. So we had to correct the text to say that there's a slight difference in which region the events get triggered in. Another errata we had said that constraints can be any SystemVerilog expression with variables and constraints of integral types. But that's already contradicted by constraint guards, and now we also, that other enhancement that I mentioned with real numbers. But assuming that enhancement wasn't in, we still needed to fix this problem. So what we did is we changed the text to say that we can deal with any type of non-random expression of any type as long as that result has an integral type. So in this example here, we can certainly deal with real numbers in a constraint because it's going to be cast to an integer value, and that value is a state variable. It's not a random variable. So the conversion or any operation that we've done is before the call to randomize. And then the last set I want to go through is clarifications. I'm just going to show a couple of them. We had about 109 clarifications. The first one is Mantis 1014. This was one of those issues that got entangled with many other issues. It wasn't clear if the line of code ifdef with a some name and a text could all be put into one line. And the way the LRM was worded, it talks about lines of text in a conditional compilation, but there's really no requirement for that because new lines are only relevant with quoted strings, single line comments, and the end of a macro definition. So this was clarified that this code is now perfectly fine. Another problem was the use of the term blocking statement. Mantis 225, probably this was the oldest Mantis issue that we worked on. So unfortunately in the English language, block has a number of different meanings depending on how it's used. So it could be used as a noun, which describes a set of connected elements like an always block, or it could be used as a verb describing a construct that suspends execution of a process. So this was just a change to the glossary to clarify what do we mean by a blocking statement versus a non-blocking assignment versus a block of code. And the last issue I want to go over is Mantis 325. This actually started out as an enhancement request for a packed array shortcut, but it eventually became a clarification to show that it's not really allowed at all. If we look at the existing SystemVerilog syntax, we can define a packed array 7 down to 0. So that defines an 8-bit wide vector with bit 7 being the most significant bit, meaning that bit 7 has a value of 128. And when we defined an unpacked array, we can define an array of 100 bits with a range like 0:99, or we can use a shortcut that implies the range is between 0 and 99. Now the enhancement request was to sort of do the same thing with the packed array dimension, but the problem was, should this be a range from 0 to 7 like an unpacked array, or should it be 7:0 with the range like most packed dimensions? If you look at the current syntax of SystemVerilog, an int is a shortcut for bit signed 31 down to 0. where 31 is the most significant bit and 0 is the least significant bit. And there's also a select of an expression, and bit 0 is always the least significant bit. So the committee decided that this enhancement wasn't worth the confusion it was going to cause, regardless of which way we decided to make the ranges go. So we clarified the text of the LRM to explicitly state that this kind of the shortcut is only intended for unpacked arrays. In summary, if we look at everything that we've gone through, we went through 32 enhancements, 61 clarifications, 109 errata, and also not shown here is that we closed 180 issues not requiring any action. So these were like questions that people had, or things that people thought might be a problem that turned out to be already fixed, or duplicates. So we went through that. I want to thank you, and just a final disclaimer that this 1800 LRM has not officially approved by the IEEE when I did this presentation, and it is subject to change depending on how the balloting process goes for the standard. Many features have already been implemented in some form in some tools, and you need to check with your tool vendor for more details about schedules. And now I'll take any questions.